Okay. This will be 2 to the 10 plus 8, so I hope everybody got 2 to the 18. Not 4 to the 18, but 2 to the 8. Any question there? The alternative would be, if you don't use the rules of exponents, would be to go, all right, this is 2 times 2 times 2 times 2 times 2 times 2, 2 times 2 times 2 times 2. That's 10 of them. And then 2 times 2 times 2 times 2 times 2 times 2, 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, there's 18 twos. And let's just hope it's not 2 to the 103 times 2 to the 84. But that's why we have the rules of exponents. Instead of having to write them all out and count them, you have the exponents. So if it was something as foreign as something like this, 2 to the 10x plus 2 to the 8x, this would just be 2 to the 10x plus an 8x, 10x's plus 8x's, that's 2 to the 18x's. You just still add the exponents. Rules don't change. That's the greatest thing about math. It's never going to lie to you. It's never going to cheat on you. It will always be loyal to you. It's never going to break the rules on you as long as you follow their rules. It's going to be a good relationship, but you got to be able to work the relationship based on the rules. Okay. In the parentheses, there's nothing we can do. Order of operations, you can't simplify it. So we can just drop the parentheses if we write it from left to right. 3 times x squared times 2 times x to the 5th. And then a little something called the commutative property of multiplication. We can switch the order between those two terms. And it's 3 times 2 times x squared times x to the 5th. 3 times 2 is 6. X squared times x to the 5th. Add the powers. 2 plus 5 is x to the 7. So this is equal to 6x to the 7. Do you have to show all of this? No. Because you have the shortcuts, you have the rules. Hey, 3 times 2, you multiply the coefficient, that's it. X squared times x to the 5th, you add the exponents, 2 plus 5 is 7. 6 equals 7. But it's going to take practice. It's going to take practice. Now, we went over why, if I wrote out 10 twos and 8 twos, it adds up to 18 twos. So a demonstration of why we have the exponent. But a demonstration of why we multiply when it's a power to a power. So number 3, let's pretend we don't know the rule. Let's pretend we don't know this rule, because that's what this one is. That's number 3. So number 3, if you have y to the 3rd and you're going to square it, what this means is y to the 3rd times y to the 3rd. That's what squaring means. You square it. Now you're just adding the exponents. Now we're just going to add those two exponents together. This is y to the 3 plus 3, and that's y to the 6. Which is the same thing as y to the 3 times 2. That's y to the 6. So if you take it a little bit further, if it was x to the fifth raised to the fourth power, you would have to go x to the fifth times x to the fifth times x to the fifth times another x to the fifth. And then you would have to go that x to the 5 plus 5 plus 5 plus 5. And 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, so it's x to the 20th. Or power to a power, 5 times 4 is x to the 20th. And that's rule number 2. A power to a power. It's got to be in parentheses to be able to raise it to a power. That's the only way you know it's being raised to a power. Guys, I got people kind of, you don't know, but you're getting some steam, guys. Because, well, I'm having to talk over. And remember, everything's being recorded. So if people try to look at the video later, then they're just going to hear me with that. For some reason, my voice is bad. I don't know. Hey, my wife did some stuff there. Well,
Maybe you feed your baby.
I just do that. Don't remember Thursday, Friday, or Saturday.
Oh, my goodness.
Anyway, has to be in parentheses. We went over something like this. What's this equal? Good, because the negative is not being squared. This is just a negative, and then you have an 8 times an 8. The negative is not being squared, so negative 64. What about that one?
Negative 125.
Not even close. You know why? This is just negative 5x to the third.
X getting the exponent.
There's no parentheses around that 5. The only thing being raised to the third power is the x. So take a look. You cannot do what's not there. And that's one of the things is sometimes we think we see things and they're not there. So negative 5 and then an x to the third. It's not in parentheses. The only thing being raised to the third is the x. So order of operation, parentheses don't have exponents. The only exponent is x to the third. Don't know what x is, so that's done. Multiply, divide. Well, I can't multiply because that's an x, and so that's done. No division, no addition or subtraction. Hey, you know what? That's what it is. But you know how many times I'll see 125? All the time. Because as soon as they see that power of 3, they apply it to everything to the left. The only way it's going to be 125 is if it's in parentheses like that. Now you're cubing everything. Which is this one right here. First question, is it positive or negative? Going to be a negative. Is the negative part of the square? No. The only thing being squared is the x to the 4th. So this is going to be the negative is waiting on the outside until you raise that to the 4th power. So that's x to the 4th times 2. Power to a power you multiply. So negative x to the 8. And again, you don't have to show this middle step. But the reason why we get negative x to the 8 is because it's a power to a power. It's okay, but remember, you're going to probably have, all right, negative x to the 8 plus 5x to the 8. You're going to have to combine by terms. That's a horrible 8. And so you might have some stuff. So if it's in parentheses, you might treat it as something else. But if it's in parentheses, it's not wrong. Okay. Now we got a long expression. So parentheses, it's always starting with the order of operation. In the parentheses, that's an X and a Y. You cannot do anything with it. So it's X to the fourth. We can drop the parentheses, and so we can go times an X squared times a Y squared. Now I'm just putting little multiplication symbols in between because it is. Inside this parentheses, there's nothing you can do because that's an X and that's a Y. So times an X to the second and a Y to the fifth. And then you have a Y to the second left over. And it's all multiplication. So then, again, with the commutative property of a multiplication, you can rearrange the terms. And all I got to do is switch these two to get the x's in order. So all I have are x's, and then all I have are y. X to the fourth, x to the second, and now I'll have another x to the second. And then I have times a y to the second, times that y to the fifth, times a y to the second. When I multiply all these x's together, we're going to add the exponents. 4 plus 2 plus a 2 times this y, and add these exponents. 2 plus a 5 plus a 2. 4 plus 2 is 6 plus 2, that's x to the 8. Times y to the 2 plus 5 is 7 plus 2, that's y to the 9. And try to show work like this on the board so you can follow along and know exactly what I did. Exactly what happened. Do you have to do all of this to get here? No. If you're looking at this problem and you realize that's simplified, there's nothing else you can do in here. It's all multiplication. That's simplified. So you know you're just going to multiply the x's. You're just going to add their exponent. 4 plus 2 plus 2, that's x to the 8. And then the y's are going to multiply, so 2 plus 5 is 7, that's y to the 9. But again, you got to recognize what rule it's going to apply to. I can always throw a curveball right in here and go, all right, this one has an extra power 3, like that one over there. So there's some things you got to take care of first. So let's do that last one, number 8. Three z to the third times -2 y z to the fifth cubed times x squared y to the third z, and then raise that to the fourth. Okay. I'm going to show you something. Don't panic. This is where you should be. You should be right here. 3z to the third times -8y to the third z to the 15th times x to the 8th y to the 12th z to the 4th. So that's -24 z to the 22nd. Nope. Let's do in order x to the 8th, y to the 15th, z to the 22nd. That's where we should be. That's a goal. That's not where you have to be. That would be the bare minimum work I would expect to see on a test. I would have to see at least that much. So there's the answer we're headed for. Negative 24 x to the a, y to the b, z to the 22nd. So order of operations, here's how it all breaks down. Math is loyal, it's never gonna let you down until it's gonna follow through. This is the first time we're gonna use rule 3. If you have a product to a power, let's say you have x times y, and you raise it to the third. So that means xy times xy times an xy. So you would rearrange it so you have the x's in order, and then you have the y's in order. So you have the x's raised, there's 3 of them, and then you have y raised to the third. Which means that factor gets its own x to the third, and that factor, that y, gets its own to the third. So instead of having to do this times itself 3 times, and then do this, and then do that, you can just raise each factor to the third power. A times b to a power. Each factor gets that power. So there's no parentheses, so that's still 3z to the third. We have a parentheses to the power. So each one, the -2 gets a third power, the y gets raised to a third power, and the z to the 5th gets raised to its own third power. Everybody in that parentheses gets raised to the third power. Now, if you notice, when I raise each one, except for one, I raise that -2 to the third, but I put parentheses around it because the negative is part of the base. I want to make sure I cube the negative. Same thing here. That's z to the 5th. So when I cube it, I want to make sure I cube it as a power to a power. And then in this parentheses, x squared is going to get raised to the 4th power. Y to the 3rd is going to get raised to the 4th power, power to a power. And then z is going to get raised to the 4th power. So order of operations, you do what's in the parentheses. There's nothing you can do. So then you do exponents. Well, exponents, you have to take care of this parentheses to that power and take care of that parentheses to that power. And this is where you're at. That might think it, oh, that's a lot messier. Well, it just makes the next step a little cleaner. Because now we have 3z. And here, parentheses still, -2 to the 3rd is -8. That's just y to the 3rd. Power to a power, you're going to multiply. So that's 5 times 3, that's z to the 15th. Times power to a power, 2 times 4, that's x to the 8. Power to a power, 3 times 4, that's y to the 12. And then we have a z to the 4th. The parentheses are done. Simplify. So now when we drop the parentheses and multiply everything, try to go to this step. You don't have to, but try this step. You know you're going to multiply the 3 times the -8. What's the next variable alphabetically? X, Y, or Z? So the x's, well, let's see, x, this is the only x, so x to the 8. And so I took care of that one. And then the y's. So I have a y to the 3rd. And I got times a y to the 12. And then my z's, I got a z to the 3rd. I got a z to the 15th. And I got a z to the 4th. So everything has been accounted for. Checked off. Positive times a negative, that's a negative 24. X to the 8th is as simple as it's going to get. Add up those exponents, 3 plus 12, that's y to the 15th. 3 plus 15 is 18. 18 plus 4 is 22. The more you practice, the more steps you can actually do at the same time. Now, are you gonna do something that ugly? Well, technically, yeah, as a practice, as a test question, in real life, no, nobody's just been touched with stuff in there. But the concept is, can you organize information and simplify by following rules? Because if you're not able to follow rules on these kinds of problems, how are you going to follow rules when it comes to actual problems in real life? You've got to have that discipline. Order of operations, rules of exponents. If you're going to survive chemistry, it's all about exponents, logarithms, things like that. So that's why I'm emphasizing it so much. And I know when I say it's a, the word I'm going to say, it's a weakness. It is something that is just not taken to heart that I see in students, or something that's been emphasized before by other levels of education. Because when I get students here, it's like, I've never seen this stuff.
Are there like practice questions like this on the
Like, yeah, you can pull up if you just, hit search, rules of exponents. In fact, homework number 5, 0.5 is all about rules of exponents. So I'm kind of getting us here. There's 10 of them. So we're at number 3 before we get to homework number 5. And right now, all the homeworks are up. 0.1 to 0.5, that's all there are. You can work at them at your own pace. If you want to get ahead, that's perfectly fine. And when we come back, we're going to do some conversions as our warm up, and then we'll get back into homework 0.1, 0.2. But I'm also going to show you how to work the quiz on Pearson, because that's what you're going to have on Friday. Okay. And I'll talk about quiz preps and practice quizzes so you're ready to take it. Okay, come on back at 9:30.